Hi everyone, this is VK. Welcome to Smid World. Here I am with another video. Grinding with ball mill systems, separating, separating, separating process, separation in third generation separator. Basic function: material enters the separator at the top. Air stream is generated by external fan. Third one, material falls down between rotor and guide vanes. Fines are stuck in. Coarse particles are accelerated by rotor and stopped by guide vanes, where they slip down and leave the casing at the bottom. Fourth point. Fine material exits with airflow at the lower or upper part of the casing. Product fineness is adjustable by the rotation speed of rotor. You'll see a picture, the material flow, feed, centrifugal force, air guide vanes, turning edge rotor, returns, air with fines. What is the separating efficiency depends on material, fineness, amount of feed, feed distribution, then air, in air, volume and distribution, then the fineness relationship will filter. Possible causes that limit the separating efficiency. The typical situations of third generation separators are uneven airflow and or feed distribution to the floater. Reduced separating airflow due to separator fan damper not at maximum, fan nominal too low, limited rotor speed due to mechanical problems or insufficient normal capacity of the motor or gearbox. Contamination of the fines by coarse product. Separator fines much finer than final product. Trompe curve key parameter. Trompe curve probability for a particle to be in the return. Separator fines, separator return. Bypass is one of the best indicator of the separator efficiency. Trompe curve key parameter. Coarse in fines. Amount of material, circulating load, separator performance, circulating load factor to cement fineness, separator performance, bypass to circulating load factor, air volume, separator specific feed load, you can see the formula, lesser than 2.5 kg per meter cube. Separator specific fines load, separator specific fine load should be 0.7 kg per meter cube. Air distribution, uneven airflow distribution. Uneven airflow distribution can be identified from observation of the ducting configuration, general arrangement, relate to position inlet or outlet air ducts, uneven wear of paintings or steel along the guide vanes height, uneven wear of paintings or steel along to rotor blades height, low separator efficiency despite low material specific loads. How to determine the airflow profile? Uneven airflow distribution can be identified and evaluated from airspeed mapping at the inlet of the separator, volute, and static pressure profile in each duct. Third point, fineness comparison of the fines at each cyclone means mass balance for each cyclone. Solutions for even airflow profile. Even airflow distribution with air guide plates. The positioning and length of the air guide plates should be done considering the airflow distribution in the ducting. Means start from where the air is already evenly distributed. Too short, good, laminar and even flow across the whole duct section. You can see in Venn diagram. Feed distribution lesser than 50. It should be means in between the separator, top liner plate and chute. It should be lesser than 50 mm. Symptoms of uneven material distribution. Uneven wear of paintings or steel of the impact frame. uneven pressure loss, and fineness of the fines in a cyclone air separator. Separator efficiency is low in spite of low material specific loads. Configuration of air slides from separator discharge to separator feed points. Solutions evaluation. Even as much as possible material loads to all separator feeding points. Adjust install mixing boxes. Change air slides configuration. The fineness relationship will filter separator fines. If F finer than C, you can check the below mentioned points. Send MF to the separator feed. Cut finer at the static separator. Reduce mill ventilation. Consider a static separator. Separator operating points. Rotor speed of nominal to air of nominal. Separators. What is separating? Splitting given material by particle diameter. Balls with 2, 4 and 10 mm diameter. Separation by cut point of 3 mm. Example by sieving. Efficiency of separation is never perfect. Separation efficiency. The efficiency of a separation device is a measure of the proportion of unseparated material following the separation process. It indicates how much fines is in the coarse fraction remaining and how much coarse in the fines. And the efficiency is very much depend on the separator. Modern cage rotor separator shows a far better efficiency than older static and dynamic separators. Basic working principle separators. Accelerated by a vortex or rotating device into the direction of the separator wall. FZ. You can see FZ in the picture. The big particles hit the wall or the guide vanes and slip down because they are too heavy for transport by the airstream. The small and light particles are carried out by the separator airstream supplied by the internal or external fan. The centrifugal force is smaller than the impulse of the airflow. The changes of airflow or distribution speed leads to different product fineness. Main separators used in cement works. Static separators and cyclones are moving parts and fineness adjustment by our mechanical modification. Second, dynamic separators means the first generation. Counter blades, distribution plate and internal fan or fineness controlled by mechanical adjustment or counter blade speed range. And dynamic separator second generation features as first generation but external fans and cyclones. Dynamic separators third generation cage rotor instead of counter blades and distributor plate. External fan fineness controlled by rotor speed cage. Static separators and cyclones. Basic function. Material enters the cyclone in the airstream at the top. A vortex is generated. A fine vortex with opposite turning direction is generated at the bottom and carries the fine material back to the top. The coarse material goes to the walls because of centrifugal force, slips down and leaves the bottom. The fine material exits at the top via the immense tube. Static separators and cyclones. Cyclones of a cement mill separator. Static separator and cyclones. Grid separator. Tailings. Adjustable blades. Immense tube. Adjusting device. Fines. Feed. Material enters the separator in airstream at the bottom. The vortex is generated in the top of the grid borne by the blades. Coarse material goes to the walls because of centrifugal forces and slips down and leaves at the bottom. Fine material exits at the top via the immersion tube. Product fineness is adjustable by changing the blade position. Static separator and cyclones. Grid separator. Adjusting device blades. Static separator and cyclone. KHD V-separator. Basic function. Material enters the top of separator from the top. Coarse material slips down from plates to plate and leaves at the bottom. Fine material leaves the separator at the top together with the air. Dynamic separators first generation. Basic function. Material enters the top at the top. Coarse material goes to the walls because of centrifugal force generated by the distributor plate and the counter blades. Slips down at the grid cone wall and leaves at the bottom. And fine material exits at the bottom of the casing. Product fineness is adjusted by counter blade position and rods. No counter blade speed adjustment is possible. You can see in picture parts wise: fine chamber, tailing cone, air vane, inside drum, fineness control valve rod, air reducer, main shaft and distribution hub, distribution plate, fan cone, counter blades, main fan blades, feed spout and intake cone, tailing outlet, fineness outlet, air inlet, air outlet. Dynamic separators first generation, Stervitant, internal fan, counter blades, external adjustment of fineness control valve rods. You can see pictures, air vanes, grid 1, distribution plate, counter plates, internal fan. Dynamic separators first generation, 5 for height. The basic function: material enters the separator at the top. Airstream is generated by internal fan. The coarse materials goes to the walls because of centrifugal forces generated by the distributor plate and counter blades. Slips down at the grid cone wall and leaves at the bottom. Fine material is tucked into the outside chamber and exits at the bottom of the casing. The product fineness is adjustable usually by rotating speeds of the plate and counter blades. Dynamic separators first generation, variable speed drive for counter blades and distribution plate, fan motor, fan, counter blades, feed spouts, distribution plate. Dynamic separator second generation, Policious cyclone, separation chamber, tailing cone, air vanes, distributor plate, counter blades, feed spout, gearbox, motor, fines outlet, tailing outlet, cyclones, air duct to fan, dust collection pipes to filter, return air duct. Dynamic separators of second generation, airflow direction to filter and fresh air. Dynamic separators of second generation, basic function: material enters the separator at the top. Airstream is generated by the external fan and is recirculated. Coarse material is separated by fan suction into the main casing and leaves at the bottom via pendulum flap. Fine material exits at the top of casing by airflow and enters the cyclone via gas duct. The material separated by the cyclones leaves at the bottom and goes into air slides. A part of the recirculated air together with the fine dust from the cyclones goes to a filter. The product fineness is adjustable usually by rational speed of the plate and counter blades. The dynamic separators of second generation, counter blades, distributor plate. Separators of third generation, basic function. Material enters the separator at the top. Airstream is generated by external fan. Material falls down between rotor and guide vanes. Fines are stuck in. Coarse particles are accelerated by rotor and support by guide vanes, where they slip down and leave the casing at the bottom. Fine material exits the airflow at the lower and upper part of the casing. The product fineness is adjustable by the rotation of speed of rotor. Main parts of cage rotor separator: cage rotor, bars, guide vanes in bad shape. Separators of third generation, example Policious C-pole. Separators of third generation, basic function, FLSO SAPA separator. Material enters the separator at the top. Airstream is generated by an external fan. Materials falls down between the rotor and guide vanes. Fines are stuck in. Coarse particles are accelerated by the rotor and stopped by guide vanes, where they slip down and leave the casing with tailing outlet. The fine material exits with the airflow at the upper part of the casing. Product fineness is adjustable by the rotational speed of the rotor. Separators of third generation. Example: OK crossflow separator. Basic function: material enters the separator at top. Airstream is generated by an external fan. Material falls down between the rotor and guide vanes. The fines are stuck in. Coarse particles are accelerated by the rotor and stopped by the guide vanes, where they slip down and leave the casing via the tailing outlet. The fine material exits with the airflow at the lower part of the casing. Product fineness is adjustable by the rational speed of the rotor. Separators of third generation. FLS SAPEX. Basic function of the compact version. The material enters the separator at the bottom with the airstream. The airstream is generated by the external fan. The material enters the rotor in the airstream via guide vanes. Fines are stuck in. Coarse particles are accelerated by the rotor and stopped by guide vanes, where they slip down and leave the casing on the side. The fine material exits with the airflow at the top of casing. The product fineness is adjustable by the rotation speed of the rotor. Additional functions: roller press version. Rollers press slabs enter this agglometer under the compact separator, where they are crushed. The fines go up in the airstream to the separator. The courses fall down and pass through the grid separator, where additional fines are separated and go up in the airstream. Rejects go back to the press. Separators of third generation. The Policious C-pole SM. The material enters the separator at the bottom with the airstream. It is air-swept mill. The airstream is generated by an external fan. Material enters the rotor in the airstream via guide vanes. Fines are stuck in. Coarse particles are accelerated by the rotor and stopped by guide vanes, where they slip down and leave the casing at the bottom. Fine material exits with the airflow at the top of casing. Product fineness is adjustable by the rotational speed of the rotor. Separators of third generation. Separator SKSD for RP circuits. Separator SKS LS for ASM. Separators of third generation KHD separator. Separators of third generation KHD setmaster. Basic function: material enters the separator at the top. Airstream is generated by external fan. Material falls down between the rotor and guide vanes. Fines are stuck into the rotor. Coarse particles are accelerated by the rotor and stopped by guide vanes, where they slip down and leave the casing at the bottom. The fine material exits the separator with the airflow at the top of the casing. The product fineness is adjustable by the rotational speed of the rotor. Special features: SKSD means additionally equipped with a slab disagglometer at the top, used in roller press circuits. Special features: SKLS LS means used for air-swept mills. Function is very similar to Policious C-pole SMS. Separators third generation 5 QDK. Basic function: material enters the separator at the top. Airstream is generated by external fan. Material falls down between the rotor and guide vanes. Fines are stuck in. Coarse particles are accelerated by the rotor and stopped by guide vanes, where they slip down and leave the casing at the bottom. Fine material exits with the airflow at the lower part of the casing. The product fineness is adjustable by the rotational speed of the rotor. Separators of third generation vertical roller mills, row shape. Basic function: materials enter the separator at the bottom with the airstream. Airstream is generated by the external fan. Material enters the rotor in the airstream via guide vanes. Fines are struck in. Coarse particles are accelerated by the rotor and stopped by guide vanes, where they slip down, leave the grid cone at the bottom, and fall back on the grinding table. The fine material exits with the airflow at the top of the casing. Then the product fineness is adjustable by rotational speed of the rotor. Separators of third generation. You can see here picture reject cone, cage rotor, guide vane system for vertical roller mill. Separators of third generation coal grinding in VRM. Basic function coal from the grinding tables enter the separator at the bottom with the airstream used in vertical roller mills. Airstream is generated by external fan. Material enters the rotor in the airstream via guide vanes. Then fines are struck in. Coarse particles are accelerated by the rotor and stopped by guide vanes, where they slip down and leave the casing at the bottom. Fine material exits with airflow at the top of the casing. Then product fineness is adjustable by the rotational speed of the rotor. The 5-4 RTKM separator for coal mills. You can see in picture here. Separator arrangements in grinding circuits. Single pass design, mainly used where high cooling is required. This type of circuit. Standard arrangement for first generation separators. Cyclone air separator. Potential problems. Wear and sealing knot tightening. Wear and clogging. Wear and blades too short. Wear and clogging. Uneven feed distribution. Wear. Potential problems. Wear sealing knot tight. Wear guide vanes not correctly adjusted. Wear and breakouts. Cage rotor separator casing. Partially clogged guide vanes. Material deposits due to insufficient airflow or airflow distribution. Reduced separator efficiency first and second generation dynamic separators. The gap between internal fan and separating chamber bigger than 5 mm. Reduced number of counter blades. Gap between counter blades and wall of the separating chamber bigger than 10 mm. Possible consequences: desired fineness cannot be achieved anymore.